Okay, so I wanted to make a video explaining a few things about polynomials and how to work with them. So we'll start by just asking the question, what is a polynomial? So far this year, we've looked at two specific types of polynomials. We've looked at linear functions and we've looked at quadratic functions. So a polynomial is kind of like a general class of functions that contains both linear and quadratic functions, but it also contains a whole bunch of other ones. So the generic form of a polynomial, it looks kind of confusing, but once you figure out what all these symbols really mean and represent, it's not too complicated. So a polynomial is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus kind of dot 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 plus a sub 1 x plus a sub 0. Okay, so what do all these n's and a's and everything mean? So the a sub n's are real numbers. Okay, they can be any real number. So all of these a sub n minus 1, a sub n minus 2, etc. They can be any real number, so it could be an integer, it could be a fraction, it could be a rational number, it could be an irrational number, it could be positive, negative, doesn't matter. It can be any real number. N is a positive integer or 0. Okay, so n is any positive integer or it's 0. So it can't be a negative number, and it can't be a fraction or an irrational number, so it has to be an integer. So n could be, for instance, it could be 2, and when n is 2, we have a quadratic. When n is 1, we have a linear function. When n is 0, we have what's called a constant function. So we really only have this last term here, because you can think of this as a sub 0 times x to the 0. But remember, x to the 0 is always going to be 1, so we don't even really need to write it in there. So again, yeah, polynomial functions have this form. So let's take a look at some examples of what is and what isn't a polynomial. So if we look at, let's say we have f of x equals maybe x to the 5th plus 3x cubed minus 2x squared plus 7, or plus 7x minus 2. Okay, so this pretty clearly is an example of a polynomial. So all of the coefficients are real numbers. All of the exponents are integers, and the first one is a positive integer. Actually, all of them are positive, or at least not negative. Another example, this one might be a little less obviously a polynomial, but we could have, let's say, square root of 7 times x cubed minus x squared over 5 plus pi. Okay, this is a little bit less obviously a polynomial just from an intuitive standpoint, because we have an irrational number here, we have a fraction here, we have another irrational number here, but notice it still follows the same rule. All the coefficients are real numbers, they don't have to be integers, and all the powers are positive integers, or at least not negative integers. Let's look at some examples of what isn't a polynomial, though. So if you could have it, everything is all fine, and it looks like a polynomial. So we're going to start out, it looks kind of like this first example, but if we add something like square root of x in here, immediately this tells us this is not a polynomial. Okay, because we have the square root of x. Remember, a square root is basically an exponent. Square root of x can also be written as x to the 1/2 power. And all of those powers need to be integers, okay? So because we have basically x raised to a non-integer power, we have it raised to a fractional power, not a polynomial. Similar idea here, if we have f of x equals, let's say, x to the -7th plus x squared. This part is a polynomial, x squared is a polynomial, but this whole thing together is not because we have this -7. So the exponents cannot be negative, and they cannot be fractions, okay? Also, if you had something like f of x equals x to the pi power, the powers can't be irrational numbers either. They have to be positive integers. So anytime you see a negative power or an irrational number or a fractional power, you can kind of exclude right away the idea of the function being a polynomial.